Myself, I'm Ganga Bhavani, Assistant Professor in EC Department of IARE. So today I'm going to discuss about feedback concepts of feedback concepts in feedback amplifiers. So basically, why we are using feedback in amplifiers? Okay, generally an amplifier circuit is basically used for increasing the signal strength. Okay, so while amplifying, what will happen is the input signal strength will be increased. Okay, in addition to the noise that it contains. Okay, so while amplifying, the input signal strength can be increased whether it includes information or information with some noise. That is, even if the signal is accompanied by some unwanted noise, that also will be amplified by the amplifier. So this noise can be introduced in the amplifiers due to their strong tendency or due to the stray magnetic, okay, as well as electric fields. So due to the strong magnetic fields or electric fields, there might be some noise in the circuits. Okay, so thus each high gain amplifier is liable in its output to provide noise along with the signal which is required. Basically, we require only the signal, but in addition to the required signal, unwanted noise also will be amplified. So in amplifier circuits, the noise level will be significantly decreased with the help of negative feedback. So by using a negative feedback, we can reduce the noise level, okay, and by introducing an output fraction within phase opposition towards the input signal. This is how you are connecting the negative feedback. We'll just discuss about this, but in general to say, the noise level can be significantly reduced by the help of negative feedback. Okay. So the practical amplifier has a gain of nearly 1 million. That is, practical amplifier output is 1 million times the input. So because of this high gain, what are the consequences that we are going to face? What are the consequences? First thing is high level output changes and noise. So because of this high gain, there will be more changes in the output as well as hum and noise also will result. Okay, the noise level in amplifiers can be reduced by use of negative feedback. So this noise can be reduced by making use of negative feedback. Now, ideally, an amplifier should reproduce the input signal with change in magnitude and with or without change in phase. So generally, what do we expect an amplifier means? It should produce the input signal. Only change should be with respect to magnitude. That is, magnitude should be increased. And we do not want to have any change in phase or frequency, but with or without change in frequency. So change in the phase, change in the value of gain due to variation in supplying voltage, temperature, or due to components. So basically in amplifiers, what happens is due to the changes in supplying voltage or temperature or due to the components, what will happen? The gain value of the gain also will be changing. And one more consequence is what? Distortion in waveform due to non-linearities in the operating characteristics of the amplifying device. Even in the earlier classes, we have discussed that when during the non-linear region of the transistor characteristics, what will happen when the amplifier is operating in non-linear region? There will be some distortion in the waveform. Okay. So on the whole, the amplifier may introduce the noise. And what else? Injecting a fraction of device output energy back to the input is known as feedback. So what is feedback basically? Injecting fraction of the device output energy, that is fraction of the output, back to the input is called as feedback. Okay, it's called as feedback. Now, depending upon the relative polarity of the signal being fed back into a circuit, one may have negative feedback or positive feedback. Basically, you have got two types of feedback, positive feedback and negative feedback. So depending upon the polarity of the feedback signal, you have two types. Okay. So what is negative feedback? Negative feedback results in decreased voltage gain, for which a number of circuit features are included as summarized below. Okay. So negative feedback, depending upon the relative energy, depending upon the relative polarity of the signal, you are having that you are feeding back to the circuit. We are having two types: negative feedback and positive feedback. Okay, negative feedbacks results in decreased voltage gain. Okay, whereas positive feedback will drive the circuit into oscillation. Okay, Negative feedback is basically it reduces the voltage gain. Coming to positive feedback, it will drive the circuit into oscillation, as you can see in various types of oscillator circuits. So typical feedback connection. Generally a feedback amplifier, how it looks like. Okay. So this is an input signal Vi, Vs. Okay. It is applied to a mixer network. Here you have got the mixer network. This is mixer network. Okay. And what we are doing here, it is combined with the feedback signal. This is basically the gain of the circuit, A. Okay. And this is what output voltage V0. So V0 you are taking back and you are giving through the feedback circuit. You are applying the feedback signal Vf again to the input. Okay. So a portion of the amplifier output V0 is connected to the feedback network beta. Okay, which provides a reduced portion of the output as feedback to the input mixer. So Vi, when you are giving to the forward circuit, that is general circuit, what happens? Amplifier circuit, you are getting some output voltage V0. Okay, that output voltage V0 is given to the feedback network beta. This feedback network beta will produce signal Vf, okay, which is a reduced portion of the output signal. So this Vf is given to the summer. So what this summer does, summer or mixer, what it does, now Vs, now depending upon the polarity with which you are adding the feedback signal, here if you see in the figure, I am giving the feedback signal with negative polarity. Means what? It is negative feedback signal. Okay. So if you are giving the feedback signal with the positive sign, that is in phase with the input, then you will call it as positive feedback circuit. Okay. So if the feedback signal is of opposite polarity to the input signal, as here input signal I am giving with positive polarity and output signal, feedback signal I am giving with negative polarity. So what this is called as negative feedback. The same thing if I do on the other hand, the feedback signal is applied with the positive polarity, then you call it as positive feedback amplifier. So A is gain of the amplifier and beta is nothing but called the feedback network. Okay. So while negative feedback results in reduced overall voltage gain, one problem with negative feedback is it will reduce the overall voltage gain, but still there are many advantages. Okay, what are the advantages you can have? Higher input impedance, better stabilized voltage gain, improved frequency response, lower output impedance, reduced noise and linear operation. So these are all the basic advantages of the negative feedback amplifier. Okay, so no doubt it has one drawback, that is it is reducing the overall voltage gain, but coming to advantages, it has got numerous advantages. There is high input impedance and low output impedance. Okay, but stabilized voltage gain. Stabilized voltage gain means it is remaining constant for a given range of frequencies, and also improved frequency response and reduced noise and linear operation. These all are the advantages of negative feedback amplifier. So the amplifier can be classified into two types based on the feedback signal, as I told you earlier: positive feedback amplifier and negative feedback amplifier. So we'll see one by one in detail. Positive feedback amplifier. So the positive feedback can be defined as when the feedback current or voltage. Again, we'll classify based on whether voltage is fed back or current is fed back. You have a different classification. But now we'll just see the classification based upon the polarity of the feedback signal. Okay. So it could be either voltage or current, whatever is the feedback signal. So based on the positive feedback can be defined as when the feedback signal is applied for increasing the input voltage. Increasing the input voltage means in phase with the input voltage. Then you call such feedback as positive feedback. So another name of this positive feedback is direct feedback. Okay, direct feedback is another name of the positive feedback. So because positive feedback generates unnecessary distortion, it is not often used in amplifiers. Okay, so positive feedback, it will generate unnecessary distortion, right? So for this reason, positive feedback is not often used in amplifiers, but it amplifies the original signal part and can be used in oscillator circuits. So basically, positive feedback is used in is not used in amplifier circuits. It is mainly used in oscillator circuits, whereas negative feedback is best for amplifier circuits. Okay, so when the feedback energy, whether it is voltage or current, it is in phase with the input signal, and thus it aids it. So it is called as positive feedback. So if the feedback signal is in phase with the input signal, then you call it as positive feedback. Let us just have a look at the block diagram. So if you see here, this is an amplifier. Okay, here I'm giving input signal V in, right? You are getting output V out. Usually, see amplifier, CE amplifier, it will produce the output in out of phase, 180 degrees out of phase with respect to the input. So this V naught, I'm giving to the feedback network. See, basically this amplifier is introducing 180 degree phase shift. Again, this output which is 180 degree out of phase with the input, I'm applying that to the feedback network. This feedback network will introduce another 180 degree phase shift. As a result, what will happen is the signal that the output of the feedback amplifier will now come in phase with this 180 and another 180 introduced by feedback network. So overall it is 360 degrees shift. So again it will be in phase with the input. So in case of positive feedback amplifiers, the feedback signal is in phase, that is VF is in phase with the VIN. VF is nothing but feedback signal, VIN is input signal. So VF is in phase with VIN. Okay. So that is why you are calling it as positive feedback amplifier, because feedback signal is in phase with the input signal. So let us just try to find out the gain, and also we'll see the advantages and disadvantages of the positive feedback amplifier. Okay. So input signal Vin is given by Vs plus Vf. So, see, as you can see here, since both are in phase, so so when you're adding them in phase, what will happen? What will be the input signal now? Vin plus Vf. Okay. So input signal of the amplifier will now be Vin equal to Vs plus Vf. That is Vs plus Vf. So coming to gain, what is gain? AF equal to V naught by Vs. So AF is nothing but gain of the amplifier with feedback. Without feedback, it is just represented by A. Gain of the amplifier without feedback is A. So gain of the amplifier with feedback. Including feedback, the gain of the amplifier is given by AF. Gain with feedback. So gain with feedback is given by V naught by Vs. V naught by Vs. So V naught by. So from this equation, can I write Vs equal to Vin minus Vf? Okay, now. See here you can see. Okay. So AF equal to V naught by Vin minus Vf. So it is now, what am I doing here? I'm just trying to divide, take this V naught to the denominator. So I get here 1 by, so I get here 1 by Vin by V naught minus Vf by V naught. So it is equal to 1 by Vin by V naught is nothing but A. Okay. See here. This is basically input signal is here, it is Vs, and after adding here, so after mixing, what do you get here? This is given with plus sign and this also is given with plus sign. So here you get Vs plus Vf. This is nothing but equal to Vn. Okay, now Vn equal to Vs plus Vf. Okay. So now it is just 1 V naught by Vn minus Vf. So if I take V naught to the denominator, I get 1 by Vn by V naught minus Vf by V naught. And from this figure, we can see what is Vn by V naught? 1 by A. Because basically A is V naught by Vn. So 1 by A is Vn by V naught. So Vn by V naught, I'll replace it with 1 by A and Vf by V naught. Feedback network. If you observe this feedback network, here you are giving V naught and this is Vf. So what do we get? Beta equal to Vf by V naught. Beta equal to Vf by V naught. And what is A? A equal to V naught by V in. So from this I can write V in by V naught equal to 1 by A. Okay. And Vf by V naught equal to beta. So it is simply 1. Again, if I take LCM for both, I get 1 minus A beta and A goes to the numerator. So what I'll get? A by 1 minus A beta. Okay, so gain of the positive feedback amplifier, that is gain of the amplifier with feedback, is given by AF equal to A by 1 minus A beta. This is in the case of positive feedback amplifier. AF gain with feedback is given by AF equal to A by 1 minus A beta. Okay. And A beta is, A is gain of the amplifier without feedback, and this factor A beta is called as loop gain. A beta is called as loop gain. Okay. So let us see just advantages of the positive feedback amplifier. So advantages, coming to advantage, it has got only a single advantage, that it can be used to generate the oscillations. So basically, if a positive feedback amplifier is used in oscillators. Okay. Coming to disadvantages, it increases instability, reduces bandwidth, increases distortion, and also increases noise. There are a number of disadvantages with positive feedback amplifier, so it is generally not used with amplifier circuits. Okay, so positive feedback is generally not used in amplifier circuits. What are the disadvantages we can have? Increasing instability is increased, reduces bandwidth, and also it will increase distortion as well as noise. So this is all about positive feedback amplifier. Next we'll see what is the negative feedback amplifier. So it is exactly opposite to that of the positive feedback amplifier. There we have feedback signal with positive sign, that is in phase with the input signal, whereas here we'll be giving the feedback signal out of phase with the input signal. That is, if input is added with plus sign, then feedback signal will be added with negative sign. So negative feedback can be defined as if the feedback current or voltage, whatever it is, it can be applied for reducing the amplifier input. So overall input will be reduced now, because the second feedback one you're adding with negative sign. So this is called as negative feedback. Inverse feedback is another name. Okay. Inverse feedback. Another name of negative feedback is inverse feedback. So this kind of feedback is regularly used in amplifier circuits. Positive feedback is regularly used in oscillator circuits, whereas negative feedback is regularly used in amplifier circuits. So when the feedback energy is out of phase with the input signal, as I told, feedback signal is given out of phase with the input signal, then it opposes it, so what it is called as negative feedback. We'll just see the block diagram. Same here, this signal is Vs. Now this amplifier, so here I'm giving, if I use summer or mixer here, okay, this is given with positive sign and this is given with negative sign. Okay, this is Vf and this is V0. V0 is given to feedback amplifier. Okay, and Vs minus Vf. Vf is given with negative sign. So what will be the output of the mixer? Vs minus Vf. This is nothing but equal to V. Okay. So in negative feedback amplifier, basically this amplifier circuits introduces 180-degree phase shift. Okay. So the output of the amplifier will be out of phase with respect to the input Vs. Right. Now coming to this feedback network, the feedback network that you are using in negative feedback amplifier, it is used such that it will introduce 0-degree phase shift. Okay, the feedback networks that you are using in negative feedback amplifiers will introduce 0-degree phase shift. So 0-degree phase shift, then what will happen? 180-degree phase shift. So what it is? Vf is out of phase with respect to the input. Vf is now, so 0-degree phase, this 180-degree phase shifted signal is given to the feedback network, which is not introducing any phase shift, means even Vf also will now be out of phase with the Vs. Okay, so this is how the block diagram looks like. So now this feedback signal Vf is out of phase with respect to the input. You can see this is Vs and this is Vf, right? So we'll just see basic different factors. Input signal is given by, now what is input signal? In positive feedback it was Vin was equal to Vs plus Vf, whereas here Vin is equal to Vs minus Vf. And coming to gain is again, overall gain is what? V0 by Vs. Okay. So this is equal to V0 by, what is Vs? From this equation, how can I write Vs? Vs is equal to Vin plus Vf. So it is Vin plus Vf. Again, taking this V0 to the denominator, you will get 1 by Vin by V0 plus Vf by V0. So this is equal to what? Sorry. So this is equal to 1 by, what is Vin by V0? Gain of the amplifier without feedback. That is, it is simply equal to, V0 by Vin is A. So Vin by V0 is 1 by A plus Vf by V0. Vf by V0 is nothing but gain of the feedback network. It is equal to beta. So on simplification, you will see that it will be equal to A by 1 plus A beta. If you try to remember, a gain of the positive feedback amplifier was with feedback was given by A by 1 minus A beta, whereas that of the negative feedback amplifier is A by 1 plus A beta. Okay. So here AF is nothing but gain of the amplifier with feedback. A is equal to gain of the amplifier without feedback, and A beta is again loop gain, same as that of the positive feedback amplifier. So if we just look at the advantages and disadvantages given by negative feedback amplifier, coming to advantages, it has got number of advantages, that is stabilization of gain. Gain is stabilized. Okay. It offers high input impedance, low output resistance, and increased bandwidth, decreased distortion, and decreased noise. So these are the various advantages of negative feedback amplifier. Coming to disadvantages, this will reduce the overall gain. That is only drawback with the negative feedback amplifiers. Otherwise, it has got number of advantages. We'll just try to summarize all what we have seen today. Okay. So basically, why you're going for feedback? If feedback is not used, what will happen? Generally, the amplifier circuit, it will increase the amplitude of the input signal some million times. So in such case, what will happen is, if the input signal is accompanied by some noise or distortion, the same thing also will be amplified at the output side. So to overcome this problem, we'll make use of feedback. Okay, in particular, in case of amplifiers, if you discuss, negative feedback will reduce all these adverse effects. Okay, so we have seen various consequences because of the high gain of the amplifier. That is, it will simply introduce hum and noise, distortion. Okay, and change of gain, and waveform will be there will be distortion in the waveform. Okay, noise will be increased. We have seen these all consequences. To overcome all these consequences, we make use of feedback. Okay, so again, based on the polarity of the signal that you are feeding back to the input, you have got two types: negative feedback and positive feedback. So positive, generally feedback signal block diagram is this. This is input signal. This is basic amplifier circuit. Okay, part of the output is fed back through the feedback network to the input. Now, depending upon the polarity with which you are adding the feedback signal, if it is you are adding with the negative polarity, you will call it as negative feedback. If you are adding the feedback signal with positive polarity, you are calling it as positive feedback. Okay, and we have seen the block diagram of positive feedback amplifier, and we have even seen the derivation of gain. Gain of the positive feedback amplifier is given by AF equal to A by 1 minus A beta. Here AF is gain with feedback, this is gain without feedback, and A beta is called as loop gain. Okay, here you can see Vin is equal to Vs plus Vf. That is, you are giving with positive feedback. Okay. and it has got only one advantage, that it can be used to generate oscillations, but there are a number of disadvantages while using positive feedback amplifier. So all this can be overcome by making use of negative feedback amplifier. A negative feedback amplifier, we have seen, it is also called as inverse feedback. And why you are calling it as negative feedback is you are feeding back with out of phase. That is, feedback signal is fed out of phase with the input signal. That is why you are calling it as negative feedback. Okay. So this is a block diagram of negative feedback signal. Here Vs minus Vf is given as input to the amplifier. So Vin is equal to Vs minus Vf. And feedback network in positive feedback amplifiers, it will introduce another 180-degree phase shift, whereas in negative feedback amplifiers, it introduces zero phase shift. So what the same out of phase signal is again applied as input with negative sign to the input. So gain is given by A by 1 plus A beta. Okay. And these advantages, it has got number of advantages. So what are all the problems we had with positive feedback amplifier? That is a low input impedance or high output impedance, or instability in gain, or more distortion and noise. Those all can be overcome by making use of negative feedback amplifier. And only the disadvantage with the negative feedback amplifier is that it will reduce the overall gain. Okay, so this is about feedback concepts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.